Hey everybody, how we doing this evening? Joe from Joe's Computer Museum, in your face and in your eyeballs to help you learn about a new cool thing that I made. So tonight we're going to have a little bit of fun building a new product that I have put together. And this product is called the Universal Video Adapter for the Apple III computer. So a little bit of backstory about the Apple III and why you might want one of these little thingy-mabobbers. So the Apple III has a wonderful RGB output on it that has beautiful color capabilities, 16 different colors. But the problem with that is that there's only one monitor on planet Earth that can actually connect directly to that and show those colors. And that is the Apple M100 monitor with the motor in it and all that stuff, the RGB monitor. Well, I wanted to fix that because I'm tired of the Apple III not having enough love and not having enough capabilities to do things. So I have created this little thing right here. Can you focus? Focus. Focus. Are you gonna apparently that it doesn't want to focus. Anyway, so what that adapter does is it takes the 4-bit RGB output of the Apple III computer and it converts it into three different, there are two conversions and one direct output. The two conversions, the one conversion that is it takes the 4-bit RGB and converts it to 4-bit CGA. So you can plug an old school CGA monitor, the little 9-pin TTL CGA monitor, directly into this card, and you'll have insanely super crisp color video. Colors aren't exactly the same as they are on the Apple III, but they're close. The second output is it uses a digital to analog converter chain, which is actually designed by Apple, and it is in one of their manuals for the Apple III actually. And I just copied it because they already designed it. It works. But basically, it converts that to the VGA format that a lot of analog VGA systems will expect, a 1-volt peak-to-peak red, green, blue. And then that is piped into the pin or into a connector that can plug directly into an Apple IIgs or an Apple colored RGB monitor. So yeah, you can basically plug any old RGB monitor into this. It's a 15 kilohertz monitor and it works. In addition, what a lot of people don't know is that the Apple III has a color NTSC output on that video port on the back of it. It's just inaccessible to most people because there's no connector for it. Well, this board also pipes that out as well. So even if you have an old school TV, at the very least you can use this, plug it into your Apple III, and get color video. So it's really cool. Let's say hi to everybody in the chat now that I've done talking my piece here. Who all is here? We've got Mike's Mac Shack. Hey, Mike. These Vintage Apple Tech. Thomas Armstrong. We got Mike Rojas is here. We've got Mike Mulhern. Hey, how you doing? John Meltz, Garth Beeble, Justin Morgan, Bruce from Brankus Creations is here. Adam McG is here. Thank you, Adam, by the way, for the little trade we did. We might talk about that later. Jeremy Breckles is here. Jeremy, I got your email. I haven't had a chance to dig into it yet, but I did see it. And some other stuff. Is this an upgrade to using the GONBESS 8200 with an Apple IIgs? No, it is not. This is specifically for the Apple III to allow the Apple III to use semi-standard RGB monitors that would be accessible to your average Apple II or Apple III user. So, John, howdy, my internet got fixed just in time to watch. Well, welcome to the party, sir. So the next question is this. Do we want to see this working immediately? Do you want me to see this plug straight into the Apple III and working immediately? Or do you want all the suspense of me building one first and then plugging the built one in? Very interesting. Hey, Frederick, how you doing? Very interesting. Before I even did this video, I put the tweet out all there and all that stuff. And some people, or one person actually already bought a card before I even did this official announcement. So that person, I think his name is Mick, his card is going to be built on this stream. So that's going to be cool. So Mike says, show it off and build another one. Joe, this should work with the M100 card on the 2E, correct? That is a very good question. I believe it will because the M100 card on the Apple IIe outputs the same video format that the Apple IIc does. So you can use the M100 monitor directly on the Apple IIc, I mean the Apple III. So since you can use the that monitor directly on the Apple III. So in theory, this would also work for that card. So if you had that RGB card but didn't have the monitor, that would be weird, but that's a possibility. You could then use this guy right here to then hook it up to an Apple II GS RGB monitor instead. So some people are saying, build it, please, build it, please. I want to make sure it's going to be worth watching more of this. Mike, build and end with a success. I think that is the thing. You know, Adam, I should have got, you know, see, Adam and I met yesterday and we traded a whole bunch of stuff. And I asked him if he wanted me to bring one of these, and he's like, well, I don't have an Apple III to test it on, but we didn't think about it. It would have been cool to have one in your hands, Adam, so you could have tested it. I could even have given you like my demo copy. I've got a few boards of a not as nice to put together version. I could have given you, but whatever. Maybe, you know, get with me after the stream. I'll get you one. So prove it, then build it. Yeah. So people are like half and half. Some of us want to build it, and some want to prove it. So how about we do right in the middle? I'm going to do one quick hookup, and I'm not going to show you a lot of the magic, but I will hook it up and show it working on the screen, and then we'll build it. Then I'll show it working on all 3 screens. So how about we do that? So let me switcheroo some video stuff around to see if I can make this work in a factor that you guys might enjoy. So let's do this. Okay, I'm just adjusting my monitors. Cool. So we're going to switch screens real quick. I need to go to this one. Yes. So that's my side screen. So we're going to plug some stuff in, and we're going to show it off, because why not? Okay, that's plugged in there. That monitor is on. No, let's turn that on. It is now on. Now we're going to boot up the Apple III. And I'm going to boot it to the dealer diagnostics, because that has a really good video test on it. It's not like in this this disk. Sometimes it doesn't. There it goes. Yeah, Apple III dealer diagnostics on an Apple II GS monitor, folks. An Apple II GS monitor. Ha! I.O. error. Yep. This is the actual Apple III wigging out. It just doesn't like certain things sometimes. As we know, Apple IIIs are notoriously unreliable. Oh, stop it. You can boot. You worked like 2 hours ago. You piece of crap. Should I drop it 3 inches, folks? Just like lift it up and drop it? What a horrible demo this is. Boot. You can do it. Oh, man. There, working out. There, it's booting now. This Apple III is the disk controller, and it's noisy. It's really grumpy. It needs to be the whole thing needs to be taken out of the machine and rebuilt. And there we are. So let's go down to the video test is right here. We're going to do the video test. Loading, loading, loading. You can do it. This video test takes forever to load. It's just how it is. There we are. High-res Apple II graphics. High-res Apple II page 2. High-res color Apple II graphics. Another page of high-res graphics. Super high-res, page 1. Super high-res, page 2. A high-res, whatever that means. Now, that looks very dark on here. It's dark. It's supposed to be dark. Trust me, it's supposed to look that dark. That's normal. And it's dark again. That's just how those are. Color bar test. There is your test right there. Beautiful colors. Text mode. Text mode. There's my favorite one right there. That is my favorite test. Yep. Colorful, beautiful RGB graphics coming out of the Apple II or the Apple III and going into the Apple II GS monitor. There we are. Now, what we need to do is we're going to show you building this thing. We're going to have a little fun building it. So I'm going to check on stuff. What are people saying? Super curious about anything Apple III related, and you should be, because the Apple III is a freaking cool computer, and if it gets enough love, we can get it to have enough like interest in the community to get people to preserve them and get them out of their weird hidey places and stuff like that. Rudy, if we buy this card, do we get an Apple III? I wish, man. If I had enough Apple IIIs to give out to people, I'd be doing that. Richard Techie, hi! Are all Apple III NTSC composite? That is a very good question. I would presume if there were any European ones, it puts out PAL, but I don't know. The connector on the back for composite video just puts out color composite video. So in theory, if you buy this and you use it in a PAL environment, it'd be outputting PAL out on RCA jack, but I'm not sure. I can't really test that. I'm in the United States-os, and we don't have PAL stuff here. The demo demons are hard at work. The floppy drive does, yep, yep, blah, 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 blah. Bye, Mike. This thing boots slower than a Windows PC, yeah. No, Mike, just the disk drive in this thing is just crap. Built-in diagnostics like 2E and 2C. Rudy, technically, yes. If you turn on the Apple IIe without the keyboard attached, I think it runs like an internal diagnostics loop. You can also tell it to do it by booting into the monitor and doing like an F636G type of thing. I don't remember exactly. Yes, the same test is on the M100 demo disk. Well, there you go. So, yes. Anyone planning to make a new motherboard for an Apple III like the Apple One got? Well, I got a couple Apple IIIs here, and one of them is crappy enough that I'm almost willing to strip it down and reverse it or reverse engineer or copy it. So we'll see. If that happens, it's going to be several years from now. So let's go ahead and switch camera angles. So we're going to go to face cam just for a second, because I want to show you all the bits and pieces that we got going on for this. So, of course, in this magical box, I have a whole bunch of these PCBs that I had made. You can focus. You can do it. Focus. Focus. What is it focusing on? I don't know. And then I've got a bin of all the bits and pieces to build them. So that's cool. I even have instructions, or not really instructions. So if you want one of these, want to build it yourself, I've got a layout, so it's easier to read that to build your own. And one of the coolest things, I designed 3D printed cases for it that go together in the corners here with some little nylon screws, so you can put it together. And I tried to find a brown filament that was kind of as close to that kind of dirty Apple III brown color as I could get. It's a little bit more vibrant than that color, but it's the closest one I could find. So yeah, let's go ahead and get the scope out here, and we're gonna put one together, because why not? It'll be fun. Okay, let's see here. It focused as soon as I gave up. Yes, yes, yes. Let's see. Let's go to a scope cam. You get to look at my dirty desk. And we will look at the coolness. There we are. So let's go ahead and get to building this. So the first thing I'm going to put on here is there's a little surface mount inverter, which goes right there. One little surface mount inverter. Here, do you want to see what I'm doing from a different angle? Would you like that? Would that be cool? Wrong. This one. That. Cool. Better. So there's one little inverter that has to go in here. If you buy one of these kits, keep that in mind that it takes one of these inverters. If you're not capable of doing that kind of soldering, but still want to do the kit yourself, let me know. And we can arrange for me to go ahead and put that one little thing on there for you. And then you can build the rest of the thing yourself. Switching. Yes, here we are. So let's see here. I need to, first things we need first is we need to get this little thing on here. I got to dig through the parts box and find it. It's buried. Here it is. Big strip of them. Okay, where's my snippy tool? There it is. Snip one off. There we are. Huh, I nearly cut through one. Well, I think I did cut through one. Nice. Note to self, don't do that. We'll check that one in a minute. Okay, so don't fall on the floor. Go where you live. Go here. Go there. Okay. So we need to get this thing out here. Doobie doobie doo. Be doobie doobie. Doobie doobie doo. Be doobie doobie. Come here, you. There we are. One tiny little surface mount component. What this is a tiny little inverter. It takes a 1 and makes it a 0, or it takes a 0 and makes it a 1. That's all it does. It inverts the sync signal coming out of the Apple III for use by a CGA monitor, because the CGA has a positive sync, whereas the Apple III outputs a negative sync. So it needs that to be backwards. So we need to get this guy on here like this. Where did it go? Gosh! Tiny little things. Stop moving around. Stop it. Go where I tell you go. And now it's upside down. There we are. Little flittery thing. Okay. Now we can get that soldered on. Doobie doobie doo. I contemplated designing this using a here. Can you see that better? That's better. I contemplated designing this using a full-size 7408 inverter or 7404 inverter or whatever it is, but decided not to. What is going on with this chip? It doesn't want to stay where I want to put it. Go where I want you to go. There I go. That solder does look a little bit weird. I have a little bit of a silver solder on my iron because I was doing some soldering repair of something else earlier today, but it's fine. So I need to do this little guy. Cool. It's on there. That's better. Cool. So that's on there. So now we can clean up that flux, because I'm sure the guy who bought this doesn't want all that flux all over his board. A couple Q-tips for that, or cotton swabs if you prefer the non-copyrighted term. So we use one to just clean up the excess. We use another, a little bit of alcohol on it to clean up the rest. There we go. And a pile of stuff on the corner of my bench just fell over. So that's mostly cleaned up. Pretty good. Good enough. Okay, so next, now we're going to put in the capacitors. This takes several different capacitors, mostly just some decoupling capacitors to get rid of noise. But I'm going to move some stuff around here. Stand by, just for my own benefit. There we are. Takes a lot of different capacitors, mostly decoupling, and one extra capacitor right here for. I'm trying to remember exactly what that does. I don't remember off of the top of my head. So we need one of these little 47 picofarad. It's not used for decoupling. It's used for isolation of a particular part of the signal. It like decouples some of the color or something like that. I don't know. I don't remember. Check on your chats. People are saying things. Need one of those microsoaps. Yeah, yes. I have too many apples already. You can never have too many apples. Does it have pretty? It does have pretty good image quality. Yes. And I'm glad I was able to actually show that to you. My Apple II GS has had a super blurry video for a billion years. And I was able to actually get that all tuned up just this evening and fix the focus problems on it so that you guys could see it. Here, let's get rid of this alcohol so I don't start an alcohol fire. That would suck. Get this guy put in here, and this is a 47 picofarad. That is in. Now, you guys are probably wondering my method. I'm really weird when it comes to this stuff. I tend to put components in one component type at a time instead of all at once. That's just me. It's how I do things. So we've got 3 of these, I believe. 1, 2, 2 of these. We've got 2 of these. Yes. So these are the 100 nanofarad decoupling capacitors. This just helps eliminate any noise that's caused by the ROM chip. When we get to the ROM chip, I'll explain what the ROM chip does. It's actually pretty nifty. It's a very Steve Wozniak type of way of handling some signal conversion. Those are my 1 mics or 100 nano. Get those put in there. So this goes in here. I apologize if you've said something to me and I haven't responded yet. I will look at chat in just a moment. You can go in. You can do it. You can do it. There you go. Okay, don't forget to like and subscribe, folks. Yes, do the thing. Okay. Joe doesn't have Elisa, but Adam does. Yes, he does. That surface mount component doesn't look nearly as difficult as my plan to change a 386SX16 for 386SX40. Both, yeah, those are pretty small. Pretty tiny little things. Bruce would be proud. Thank you. When you put the resistors in, do you put the value band at the bottom or the top? These resistors are mounted perpendicular to the board because I'm weird, and it saves a lot of space. But I usually put the, if you mean the value band, if you're talking about the little stripe that tells you what the percentage is, I usually put that at the bottom. That way, you know, or at the bottom or to the right. That's just the way most people read things. I guess if you were in a right to left reading society, you would do it the other direction. I don't know. Am I using lead-free solder? Heck no. No, I only use lead-free solder if somebody forces me to. Leaded solder, in my experience, just tends to work better. It flows, it gets right in the spots, it does the thing. I do want to experiment with some of the nicer lead-free solders that is supposedly do a better job. There are some basically, it's mostly tin, but with the lead removed, and it's got like some copper and silver in it, and so a couple other things. It's supposed to be better for the environment and all that stuff. but in my experience, they tend to have problems with joint fatigue on joints that have a lot of stress on them. And you have to crank your iron up higher and all that stuff too. So those capacitors are in. What's next? I'm going to pick a random value resistor out of the box here, and we're just going to grab it. This is 100s, and we need 7 of these. Of course, I picked the one that has the most. 100 ohm resistors. I need 7 of them. So 1, 2, 3, 4, 5, 6, 7. Seven of those. And then I fold these up, put them back in their little bags so I know where they are. Nothing is as good as 6337. Yeah, 6337 just, I mean, it's not as good for the environment. It's not as good for your personal health and all of that, but it just flipping works. So which way is that? The thick band is that way. So these get folded over this direction. Can I fold them over all at once? Did that work? It kind of did. Well, I won't do that again, but it worked. Cut them out of their little bandoliers here. Okay, now to put the 100s in. So these go in a whole bunch of spots. We've got right here, a couple of them here. You can do it. Go in the hole. Okay. This will be a great reference, too, for those of you who want to build one of these at home. You can just watch this stream and see how it's done. I have 19 of these up for sale. I made 20 of them. Can you guys even see me? I made 20 of them. And I kept number 1 for myself because I need one for testing and for whatever reason. And the next 19 are ready to go. If demand is super high and I got a lot of people who want a whole bunch of them, I'll do another run and do another run and do another run. Basically, I plan to just keep a small run in stock at all times. If I run out of one run, I just build another small run. That's how I do things. I don't do pre-orders or any of that weird stuff. I have absolutely no ability to like keep track of anything, including everything. So for me to have like some sort of pre-order list is like impossible. 1, 2, 3, 4, 5, 6, and there's one more. I have to hunt for where that goes because I don't remember exactly. Where do you go, buddy? Well, we've got this wonderful cheat sheet right here. I'll just read the cheat sheet. Stand by. I don't remember where it goes, where it goes, where it goes. Up, it goes all the way up here. It goes way up here. Doobie-doobie-doo. Get the resistors in here. Now, let's talk about what this circuit does. There are 3 main things that it does. The first thing is what we're working on right now, which is the digital to analog converter. What it does is it takes the 4-bit analog value for each color coming out of the thing, coming out of the Apple III, and converts it to its equivalent or expected analog color combination on the other side. If you guys know anything about resistor ladders or anything like that, you'll understand how that works. But effectively, what we're using is a combination of resistors and their voltage dividing capabilities. If you want to figure out how that works, you can do a quick Google search on resistor voltage divider. And we're taking advantage of that voltage dividerness to create a very specific and selective voltage divider that creates the voltages we want. That solder is nasty. That's better. So that out the far side, the combinations of the different red, green, and blue values come through as expected. In addition, this circuit has some extra transistors in an emitter-follower setup, whose basic job is to drive those voltage outputs without requiring the Apple III to do that driving. The digital outputs coming out of the Apple III only have so much juice they can drive, so much current they can drive, and the analog video requires, in theory, more current than what the Apple III's circuitry can provide. So that transistor circuit basically takes care of that. That's the analog section. Okay, those resistors are done. What value's next? Random value, 10K, 1. Since you're soldering, can you make my 2C keyboard encoder? It's still not in the mail. Did you order one? Did you order one, Rudy? Now you got me concerned. Stand by. I need to actually look at that. I happen to be logged into my store. Orders. Orders. Yep, there it is. I'm going to click this. Stand by, Rudy. I'm looking you up. Mm-hmm. Tracking you. Rudy, your package arrived in Canada on November 9th at 6:19 a.m. It will arrive at you whenever it arrives at you. It's been made. It's been shipped. I mean, I can make you and ship you another one, but I don't think you're going to get it any faster. What are other people saying? Yes, yeah, Plowman. Oh man, Plowman makes stuff that just makes me look like chump change, man. I'm telling you. I only seem to get the 2Cs with the bad keyboard encoders. Yeah. Now you know why they were gotten rid of. So now we need to put in this 10K resistor, which is part of that. It works together with that 47 nano capacitor, 47 pico capacitor, in whatever function that is. Again, I don't remember what it is. I know what it does, I just don't remember. So this goes in. Little 10K resistor goes right next to this capacitor. It goes right here. Focus. Can you guys see? There you go. 10K goes in. Do, 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 do. Okay, that one's out of the way. Next, whatever resistor value this is a 2K resistor. There are 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. 8. 8 is great. Steve's had food. Steve. Yes. Yeah, if you didn't catch Steve's stream, when my stream is done, you can go back and catch his. Although you'll be in for a long ride. There's a 4.5-hour stream, Steve. Spent fixing lots of stuff, and near the end, he was becoming grumpy Steve because he was hungry. He had a hungry. So we're going to put in this 2K resistor. You can go in the hole anytime you want. There's one. And another one. And another one. There were a smaller main board for the 2C. That would be a challenge. The 2C is already a pretty small board, to be honest, when you look at it. It could, the 2C plus could probably be shrunk down a little bit because it's already shrunk down, or I should say some of the circuitry was removed because it was unnecessary because they figured out ways to do something. I don't know. But I don't see that board getting much smaller. Do. You use a one-time programmable ROM? Yes, I do. For these, I use the one-time programmables. When I'm doing development, I use an EEPROM typically because that way I can use one chip, wipe it, reinstall it, wipe it, reinstall it, wipe it, reinstall it. Until I have everything figured out. When I send these out, I'm using one-time programs because right now they're cheaper. Cheaper and more reliable, honestly, than the UV ROMs or anything like that. Chip shortages are a problem, but even at this point, I believe I ordered like 40 of the 60 last of these EEPROMs that Mouser had in stock for this project. So, because I needed some more for my Apple III CPM card because I was running low on those. Because I used some of them for a project for Javier Rivera, who is in the chat. Hi, Javier. For his Atari thing. I did a video on that. If you haven't checked that out, go check that out after the stream. Fixed an Atari ST. It's pretty nifty. But yeah, these the chips are getting impossible to find right now. I mean, you can get them if you know where to look. Like Rochester Electronics, for example, has a lot of them, but you have to buy them in orders of like a couple hundred. And I'm like, I don't need that many. 1, 2, 3, 4, 5, 6, 7, 8. Those are all in there. Okay, make sure we're focused so you can see what I'm doing. Can you see it? Can you see it? It's focused now. The 2C Plus is an internal PSU as well. Yeah, there's a lot of space on the left side of the board that that's just kind of there. At least reduce the amount of RAM chips on the 2C using something more modern. Yeah, that is that's tricky. Sometimes you can replace dynamic RAM with static RAM and use fewer chips, but not always. It doesn't always work that way. It depends on the complexity of the design. If you know how to get the RAS and CAS lines figured out for the addressing and all that, and know how to latch it, it can work, but it doesn't always. Just soldering up these things. All the resistor doodles. Come, I'll ferry you. I've actually contemplated making a replacement memory board for the Apple III. By contemplated, I mean I looked at the design of the memory board for the Apple III for about 5 minutes and decided, I need to get a lot better what I'm doing before I touch that. That is one crazy, crazy convoluted board. The Apple III's got multiple different CAS and RAS lines for different banks and all this stuff, and I'm trying to convert it from dynamic to static. I have to figure out all this like logic and create a development jig and Although if I managed to do that, that would be cool because basically this huge bank of chips would be replaced with a single chip, and it would basically consume no energy whatsoever, and greatly cool down the inside of an Apple III. That would be super awesome. I do want to do that at some point. Okay, so what's next? 620s. We got 3 of these. 1, 2, 3. 1, 2, 3. 3. Everything is fixable except a cracked CRT. Yeah, to some extent, yeah. Yeah, the folks over at Atari Age were given Javier a whole bunch of crap about his Atari. They're like, yeah, well, it doesn't turn. You reverse the voltages accidentally. You broke it. You broke it. Well, you just got to try, right? You got to try and see what you can do. And in this particular case, the very specific kind of fault that Javier had, I actually found out later from somebody who commented on that video. They had the same problem and they had the exact same fault. What happens is it's the 2 serial communication, the serial buffer chips, and the MMU. Those are the 3 things that fry. You replace those 3 things and you're back online. So like, don't be a jerk, just like do it. So these 620s go in here. Go right here. You can do it. Again, this part right here, we're building the digital to analog converter. Got another 620 goes right here. And yes, I have a weird eclectic mix of resistors. These resistors just are not critical to operation. I mean, they are, but they don't have to be anything crazy. So I literally, for this project, got the least expensive resistor that I could find that met the specs. And so it's just a mix of whatever happened to be in stock. These are not crazy critical. In theory, they should all the resistors should all be nice and equally matched because we're doing this analog conversion. But I don't think you're really going to see any major issue with it unless you're like comparing 2 very badly matched boards right next to each other to see any actual color difference on the screen. It's just not that important. This isn't a highly tuned circuit or anything like that. It's just supposed to get a voltage level. That's all it does. Okay. All right. I put those away. What's next? 3K resistors. I have exactly 6 of these that need to go in. Yeah, the other thing that can be fixed is this Quadra 840AV. That I don't believe that. I do not believe that. You might have to give it a whole bunch of donor chips and sand the board down and this and that and the other, but 6 of these. Doobie doobie doo. You can do it. Okay. 3K resistors. 1, 2, 3, 4, 5, 6. What I really should do is take all of these resistors out, pre-cut them, and pre-fold them. So when I make these en masse for people, it goes faster. Steve, there could be a short through a IC time for scope. Okay. TV monitor has a deep scratch, and then Javier said glass could be polished. Yes, yes, it can. So let's see, where are we? These are 3K resistors. 3K. I believe, I don't know if I comment on Garth's comment. He said this board is very well marked. Yes. I did that so that I don't have to remember where everything goes, because, and I did that for perfectly selfish reasons, but also for those that buy this and want to build it, they can just see where stuff goes. They don't have to like do any funky deciphering. But some of this stuff is really small, and I have the benefit right now of looking at it through a gigantic microscope. You guys might not have that advantage. So I do, everyone that ships out will have one of these with it. It will have a map to help you know where the things go. Come on, go in the hole. You can do it. Is your friend. Yep. Okay. And we got another one, which goes up here. I hope you all can see what I'm doing here. I'm trying to keep things on screen, but I'm also just trying to get this done. And that one's in. Put in the next one, which goes down here. These 3Ks are mostly bias resistors for the emitter-follower network. And bias it to 5 volts. One more 3K, which I think is used in the actual voltage divider network here. Nope. Where are you, extra 3K? Did I pull out an extra one? Oh, no, it goes down here. It's a bias resistor for this one. Okay, get this soldered up. Some of the supply of the OTP parts is Atmel, was bought out by Microchips. Yeah. That is true. Okay. Now, this voltage divider network is the more interesting part of this, to be honest, because it's kind of the weird analog voodoo section. It's like, how does it work? Like, nobody really knows. Kirchhoff's law and like Ohm's law and weird theory and blah 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 blah. What is the average resistance of an infinite network of resistors? And just BS. The digital side is really, really boring. Melt, thank you. Oh, come on, work. There we are. Gum is getting mintier, have you noticed? And those are on there. What's next in the box? Not those, because I don't use those in this project. 470, sure. Got 2 of those. Did I know that the M100 monitor has an internal switch that basically turns it into a CGE monitor so it will work on a 2GS? I did not know that. 1, 2. The Apple IIgs is not. The Apple IIgs is analog though. CGA is digital. The Apple III is also digital. So I'm not sure what you mean. I would love for you to give us some more background on that. So let's do, we're doing 470s. Yes, those go up here. At the top, there are a couple of them. Well, at least one of them goes right here. This top row is mostly bias resistors for this group of transistors. And then the other one is down here and is a current limiting resistor for, I believe, the sink line. Okay. You guys can't see a gosh darn thing that's happening. There we go. There we are. Turns it from digital to analog. Well, there you go. So basically what you're saying is that the M100 monitor does the thing automatically. It has effectively this circuit in it, and when you flip the switch, it just switches how how it paths. That makes sense. Or are you saying it allows it to be a CGA monitor? I'm not sure. Yes. So what's next? 47 ohms. And there are 4 of these. These 47 ohm resistors are current limiters into the bases of the transistors, of the first line of transistors, that is. Yes, less colors. Okay. Doobie doobie doo. I folded that one wrong. No, the stripes have to be at the bottom. They must be correct. The spice must flow. Anybody seen the new Dune movie? I have not. But I hear it's nifty or something. That microscope is amazing. Yes. Yes, Adam, it really is. It's been a game changer. I had been doing surface mount stuff by eye, and surprisingly being able to do it. I don't know how, but having to not do it by eye anymore is outstanding, at least fantastic. It's just great. I mean, all of this stuff that I'm doing right now could be done by eye, but doing it with the scope is just, it's the bee's knees. The original Dune movie is always going to be the best. I mean, it's got Patrick freaking Stewart in it. Kyle MacLachlan. It has Sting in it. Toto did the music. The problem with the original Dune movie is that Dune is such a wandering epic. Like, the movie doesn't do the book justice. You can't like have a 2.5 hour movie and have it do the whole friggin' movie, the book. It's just, there's so much lore that gets cut out and glossed over because you can't fit it in the space. So, you know. So those are done. Those are the 47s. What's next? Whatever I grab next. 75 ohms. These are the final output resistors that, for lack of a better way to put it, properly throttle the heat of the, it's called impedance matching, the output of the final analog circuit that goes into the Apple II, or the Apple IIgs monitor. The final analog video. My friend Peter Petter, I almost said his name wrong, Petter Puskarich, who helped me design or test a beta version of this, will know all about these 75 ohm resistors. And he's the one who helped me determine, yes, the circuit actually does need them, because without them, it doesn't work right. I had removed them in my first run because my monitor over here, my Apple II GS monitor, has seen better days. And it worked better without the resistors in there. But I wanted to be absolutely certain, so I sent a test article to Petter without those resistors in it. And he's like, it doesn't work. I'm like, put some resistors on it. And then there was a funny 2-week period of him trying to get some resistors. And then he did. And just today, he's like, hey, what? Hey, Joe, they're awesome. It works great now. So I'm glad he said that. Okay. All right, those are in. And there we go. 75 ohms are basically analog signal terminators. The 470 resistor is in backwards. No, it is not. If you look by the way I designed it, it is in there in the correct direction. That is the way I put it in there. That's the way I wanted it. I can redesign it and put it in the other way, I suppose. It fits in there better. It's easier for you to get your fingers in there to get it in there. That way, if you look, see, there's method to my madness. That's why I designed it that way on purpose. Trust the process. Fade, lovely fade. So what's next? I don't know, whatever I grab out of here next. 270s, 4 of them. Again, these are bias resistors up here to the base of these transistors. I believe it biases them off. Doobie-doobie-doo. Now, there really is nothing fancy to this board. I've really designed very little new. That 470 is backwards. The 470 that's into the display now. Wait, hold on. It doesn't matter. It's going to get, that's the way it's going to be. Thanks for spotting it. There's nothing fancy to this design. Nothing really out of the ordinary to it. The majority of the design, everything from basically here down, is all Apple's design. I just used their layout. I figured their engineers had already figured out what was necessary to get the right colors to come out of it. So I didn't have to, come up with my own resistor ladder and do, hours and hours of like, well, what combination of resistors and what calculation of blah to get 1 volt when it comes in. They already designed it, so I just used it. The only thing that's novel is the ROM portion, which is the digital to digital converter. And I will discuss that when we get to that point. Can you tell I'm trying to leave some suspense for the part that I actually brained and did some smarts on? Just a little bit. Just a little bit. One 270. And one more. A resistor in backwards is an amp. Yes, it's a current multiplier. Exactly. You funny. Can you see it? There you go. My OCD. Ah! Well, it's in there now. I'm not taking it out. It will not affect function. It will be just fine. It's in backwards. Ah. Oh, come on. Where's my solder? There it is. Okay. Snip, 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 snip. Nice and clean. Except this one that is an absolute atrocious mess. That's better. Okay, cool. What's next? These are 1K resistors. There are 3 of these. These are part of the resistor divider network. Memory serves. I wonder if resistor packs would have worked. It might have, but I have a feeling with the way that things had to be laid out on this board in order to get the resistors in the right spots. I would have had to design it as a multi-layer board, I think, and I didn't want to do that because I didn't feel like trying to use my brain power for that much work. But maybe some of the resistor packs probably would have been okay for the 2K and 3Ks because there are like 6 and 7 of them, respectively. But if some of these other ones just have like 1, 2, 3 resistors. There's not a lot of them, so there's really just not enough to justify a whole bunch of resistor pack resistors. It may have been slightly less expensive to do it that way, perhaps. Resistor packs tend to be pretty cheap. But then again, I buy resistors in bulk, and they cost me a couple cents a piece. Yeah. Yeah. The final 1K is up here. Yes. Because basically, there's three sets of resistors here. You know, there's a bank, there's a bank, a bank, and a bank, and each of those banks have to be kind of close to the other components, unless you design it with multi-layer board, a multi-layer thing, and have all of those things those signals being transferred by an internal bus. And yeah, I'm not sure it would have worked well. I mean, feel free to prove me wrong, obviously. The board would have been a lot smaller as well if I had used surface mount components, but I didn't feel like it because I wanted this to be a kit that people could build themselves, and I wanted it to be accessible. I wanted everyday average tinkerers and makers to be able to just grab this kit and put it together and use it potentially as a learning kit too, because it has one surface mount component, one. So you can learn how to do surface mount that way, but I didn't want to overwhelm. So yes. What's next? I think all we got next are transistors and connectors. I believe that is correct. Yes, it is. Well, I need my 3904s. Stand by. 3904s. Yes. Hello, 3904s. How are you? You could use 2222s and 2907s, and you could use just about any transistor in here. I went with the transistor that the original design called for. The transistors do get a little bit of warm because they are doing quite a bit of work. So these are the 3906s, and for those I need 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to switch camera angles because I'm going to show you some stuff. Is this a 2-layer board? Yes. I'm going to switch camera angles. Give me just a second. Will the scope cam be better for this? It might be. Stand by. So I want to show you how I put these in. So looking at this right here, you can see that we've got focus so the lovelies can see it, please. There you go. So you can see I've got the outline of the actual board on here, right? Or the device. So it matches the shape of the transistor, so we know which way it's supposed to go in there. The trick is they're splayed out a little bit the connectors are apart from each other. And this is just because of standard through-hole component things and these leads being really close together and trying to get vias that close together and blah, 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 blah. It's just the standard way of doing it. Well, that means I've got to get this center pin out of the way. And I'm going to show you how absolutely stupid I am. For the longest time, I tried to get the center pin and bend it out of the way and bend it down. And it's a pain in the butt to do because the other two pins are in the way. And it suddenly dawned on me that I can actually fold the outer pins instead and leave the middle pin where it is. So basically, that's what I do. I kind of take the outer pins. It goes this direction. So those outer pins have to go forward. They have to go that way. So if we look at it like this, they have to fold up a little bit. Take the pin, fold it up a little bit. Usually I just do this with my thumb. I'm trying to show it on camera. But you just fold them up a little bit so that there's that you got that division. And then you can just wiggle it into place. Usually do the back one, a side one, then the third one. Once they're in, you just and that just kind of wiggles it on down in place, just like that. And it's in. Focus on that so you can see. Just like that. All in place. So now I got to do that a bunch more times. So let's do it. So this goes this way. Those fold forward. This goes in here. Goes down until it's level. And repeat. And repeat. You can get heat sinks for the 3904. Yes, you can. As long as you actually install the transistors. Adam was referring to a very, 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 very old mistake I made once on my live stream of building the Apple, the CPM card, the Z80 card for the Apple III, in which I spent 2 hours building this card on the stream and everything was fine. I went to test it and it didn't work. It's because I forgot to solder the transistor in place. Like a dope. He remembers. He's got a long memory. So we got those 4 in. Now we have to put in the 3 in the back. These go over here. Like this. Just so it clears the top of those resistors. There we go. And this one. That. And the last 3906. You can do it. Go in the hole. The hole is your home. Are you too good for your home? Here we are. All of those are in place. So now we solder a whole bunch of times. It is, wow, what is this, guys? Willy Wonka's Art Factory. This is the universal video adapter for the Apple III computer. It's a little thing that I designed that allows you to connect it to an Apple III and then connect an Apple II GS monitor, a CGA video monitor, or a good old-fashioned color television, or it's technically color composite, to your Apple III and actually finally get color out of your Apple III. Many people have Apple IIIs, but they don't have a color monitor because there really weren't any compatible color monitors with the Apple III except the Apple M100 monitor, which, as we all know, is freaking unobtainium and impossible to find. And if you do find one, it's in 1,000 pieces and doesn't work. And I want people to have the ability to have who have Apple IIIs or who are interested in Apple IIIs but never thought about getting one to be able to use the Apple III in all its glory. Now, granted, the Apple III is a business machine, and a lot of its functions are in black and white. But even then, wouldn't you want to use a nice, crisp, clear, high-resolution monitor for that black and white? I mean, black and white's going to look so much better on an Apple IIgs monitor than it is on, you know, I don't know, a green screen monitor. Because it'll be bright white and pretty. Easier on the eyes. That's just my opinion. So, making sure those are all soldered in place for Adam. Adam McGee. Okay. Snippy snip. That 2, 1, 2, 1, 2, 1, 2, 1, 2. Get out of there. Get out of there. 1, 2, 1. There we are. Joe, can we use composite video alongside the RGB out? You absolutely can. The composite video it basically passes straight through. I can show you here. So basically, the composite video here. Do we need to like do the thing? Yes. It comes in here. So it comes in on like this pin, then goes through the other side and flips over and comes through here. But basically, it comes straight out. You can't see what I'm showing. It comes straight out, goes up and around the outside edge of the board, comes straight to this pad, right there, and then it just connects to the connector, and that's it. That's all there is to it. So now I need 3904s, which I need 1, 2, 3, 4, 5. I need 5 of those. I could use 2222s for this. And when I was developing it, I did use PN2222s. They worked just fine. No problems. You literally use any old generic transistor. It'll work just fine. As long as you get the PNP and NPN part right. So those go this direction. Yep. Doobie doobie doo. Do 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 do. That's one's in there. Yep. Final output stage transistors to clean up the drive on the final output. That didn't focus. It kind of sort of is, kind of sort of isn't. That's a little better. That a little better for you. I even, again, trying to make this as easy a kit as possible to put together for folks. You can see I even put the outline of the transistor there. Can you even see it? The outline of the transistor matches the way it goes in. So it's basically, if you put this together and you get it in backwards, you're like me and you just weren't paying attention. It's literally that easy to put together. It's designed to be simple. Okay. In all the way, it is. There we are. I'm just checking the orientation of all of those to make sure they're correct. They are. Okay. Making sure they're all down far enough. They are. Good. Solder time. Solder. Insert tab A into slot B. How's the Apple III operating system, Apple SOS? I've never tried it. Stable or buggy, intuitive or awkward, fun to use? Yes, so that's the thing. SOS is a little bit, it is more, you can think of it more as a toolbox than an actual operating system. It was not designed to really be used directly, from my experience. Most of the disks that I've gotten, they have SOS on them, but SOS runs in the background. It just sits there in the background, and it provides services to the system. It doesn't really work like ProDOS does, even though it basically is ProDOS. ProDOS was developed based on SOS. It's the same code base. Now, if I'm wrong, and if there's anybody in the chat who happens to know better than me, please correct me. But I have not seen a disk yet that's just like a system disk that you boot to, and then it has like a command line and directories and all of that stuff. It's always a utilities disk of some sort that just calls to the OS and asks the OS to do things. Okay, yep. All righty, clip. 2, 1, 2, 1, 1, 2, 1, 2, 1, 2, 1, 2. There we go. All of the analog components, these are technically analog in this case, all of the analog components are on the board. So next, let's put in the chip. Yeah, the SE30 board, yeah. The capacitors on the SE30 are those axials, and they usually are just fine. No problem. Let's see here. Yes. So the next, let's talk about the digital component of this. The digital component of this is a ROM. It is a ROM whose entire job is to take a series of digital inputs and map them to a series of digital outputs. What this is doing in this case is taking the color value that the Apple IIe or Apple III is putting out for each of its colors and using that as an address for a location on the ROM chip. Stand by, I'm just putting the socket in here. That address, for each of those addresses, it has the corresponding CGA digital output in that location. And then those values are what gets piped to the CGA connector. You can think of it, in a way, as a state machine. It has a series of, it's got a series of, it's got a series of inputs that result in a series of direct outputs. These states in equal these states out, which is very Woznian. Steve Wozniak did the same thing in his disk controller. I have stolen that concept, that state machine concept, so many times. When you think about it, it's really the only way to do it. You know, you can do it by like some sort of funky microprocessor controller or something if you really wanted to. But like that would just be a lot of extra work. Now, the thing about this ROM is that we need 16 values and only 4 bits per value. So this ROM is way overkill for the function. It's something like it's a 32 kilobyte ROM. We're only using 16 bytes. And even then, we're only using the low 4 bits of each byte, and the upper 5 bits just float. They don't do anything. But of all of the ways that I had to do that conversion, this uses a single chip, and it is literally the least expensive way to do it. It might seem like a waste, but it costs less. So it keeps the price way, way down and keeps the size of this board super, super small because it uses a single AT27C256R. So that's in. So now we need to solder on all the adapter doodles. So I need those. You got a 15 pin for the Apple II or the Apple III side. I keep calling it an Apple II because I'm an Apple II dude. 15 pin for the output side to the Apple II GS monitor. Ah, fell on the floor. Don't do that. Don't fall on the floor. Where'd you go? 9-pin connector for the CGA monitor. Joe, the ROM on the Lisa SCSI card has 1 byte on it. Well, you know, if it's the cheapest and easiest way to do it, it doesn't matter if it seems like a waste, because it's not a waste if it's the best way. And then an RCA jack for composite out. All right, so let's get these on here. This guy goes on, it straddles the board basically and goes on both sides of the board like that. See, just like that, goes on both sides of the board. Okay. And we solder it in place. Now this is a place where I think, these connectors anyway, are a place where I think you'd find that silver-based solder would be not as good. Because, in my experience, silver-based solder does not handle strain well. And there's potentially a lot of strain happening on these connectors. You can connect to the pad anytime. There you go. Good connector. Okay. Flip it over and do the other side. Okay. Oh, stop it. Stay in one place, please, so I can do the thing. Thank you. There we are. Yep, that's on there, not going anywhere. All right, so let's put on the Apple III side, which is over here. You may have to do this off camera. This is a little footery, as Big Clive likes to say. Okay. It's not quite correct. Stand by. I'm just juggling it over just a little bit. There we go. All right, that's in place. Good. Joey like. Okay. Rudy's Retro Intel asks, what soldering iron do you use? Think time to replace my 30-year-old Weller soldering iron. I use a Kistner T12 soldering station. I use a standard T12 tips. It was insanely cheap. It's something like 80 or 90 bucks. However, there are better ones out there. Of course, I'm literally the cheapest human being on earth. If I can get away with doing more with less, I will find a way to do more with less. That's just how I am. I'm a product of my upbringing. But there are better irons out there. The Hakko 936 series, I think it's called, is a really good iron. It uses the same T12 tips, but the iron, the base itself is of a little bit better quality. There's also this really cool USB 3 soldering pencil that Adrian's Digital Basement uses that I think is pretty schmick. So you could try using one of those as well. I used to have links to all of my stuff in my description. But I stopped doing that because I couldn't find a good way to keep it up to date. There were some services I tried to use that to do it, and they didn't pan out and whatever. I tried the Amazon affiliate link thing, but I didn't get enough referrals through it for them to allow it to stay open. So yeah. If anybody is wondering what this connector type is, this is called a solder cup connector. It is designed specifically for exactly what I'm doing, for this kind of board edge connection stuff. I like them because they work for that board edge stuff, but they also do a really good job for just taking wires. Just making sure these are all nice and flowed well. There we go. Now we got to put the other end on. This is the end that goes to the Apple IIgs monitor. It is a female end. It's designed to take the Apple IIgs video cable. So you can just plug your cable straight in. Could this be used to connect a 2GS computer to a VGA monitor to bypass that awful GONBEZ 8200? The answer to that is no. You cannot do that. This is not what this is designed to do. It would not do the thing. Don't I have a kit site? Yeah, I did have a kit link, kit.co or whatever it is, but it stopped working. Let me see if I can find it. Stand by. Yeah, it's not there anymore. I had one, and it just they never kept doing it, or like it just stopped working. Like it just disappeared. How to boot ROMs, Apple III emulators, Raspberry Pi. People are asking questions that aren't to me, and that's fine. Does this DE15 plug straight into the Apple III port? Yes, it does. I will show that off a little bit later. You should try affiliate links again. Joe, you've probably got enough subs now to make it work. Yeah, a couple of $100 a month from affiliate. Gee, mini Christmas. I really do need to try that. Man, that'll fund everything. Sean's here. Hi, Sean. How are you? The Pinecil by Pine64. Yes. He swears by that thing. So, and I would almost be willing to say he does more soldering than me. So, you know. Yes, these are DA15 connectors, whatever you want to call them. 15 pin with solder cup termination is what it's called. Solder cup. See, they're little cups, and they take solder. Or solder, as the friends across the pond like to say. Because it does have an L in it. Just because us Americans mispronounce things doesn't mean that's the way it's supposed to be. Yes, I've been... stand by. That is my take your medication, Joe, reminder. But I already took it, so it doesn't matter. I've been team solder cup for a long time. You see, that's the thing. You know, Adam, you're making all this money from affiliate links, and so is Bruce. I had my affiliate links on every freaking video I made for like a year and a half and made exactly $0. Yes. What is Flex used for? Exactly what Thomas Armstrong said. Basically, it removes the top layer of oxides so that the solder can actually bite onto the metal. Solder is very interesting stuff. It makes a very thin surface amalgam or alloy between itself and the metal it's bonding to. But it can only do that when it can actually touch the metal itself. Almost all metals will get this surface layer of oxide on them, sometimes called a passivation layer. And you have to have a flux that helps burn off or deoxidize that oxidation so that the solder can get straight to the metal. That's what it's used for. Flip it over to the other side. The solder that I'm using has flux built in. If you look very carefully at the top edge of this as it flows up the cup, you'll see some little like yellowish stuff. That's the solder flux coming out of the core of the solder, which is perfectly fine for just doing quick jobs like this. But when you're doing things where you have to carry the solder, see, how can I put it? Right now, I am giving the solder to the joint as I'm doing it on the fly, right? So the flux and everything is right there. But you see all that vapor that comes off every time I touch it to the iron? That's that flux burning off. So if you're doing something like surface mount, where you can't just like touch the solder straight to the joint, just because there's no space, room, whatever to do that, you need to add a little bit of liquid flux to the board while you're doing that. You can't see a gosh darn thing I'm doing. That's the problem with this scope. That's the one problem I have with it, is getting it in framed where I can see it and where you can also see it is a pain in the butt. Squirt flux on a T1000 and I'll get stuck to things. That's great. I love that. Flux is especially useful with capacitors. Yes, because then it becomes a flux capacitor. Do you get the joke? Don't use plumbing flux. No. No, you have to use flux specifically designed for electronics because the metals that they use are slightly different. Okay, and we're going to put the CGA connector on. And once this is on, then we program the ROM and we should be done. There we go. That one's in. Can you see that? You can actually see it now. Okay. Attach it. See the flux go up. Flux. Oh, you can do it. You can do it. All right, there's that side. Flip it over and do the other side. Yeah, Jeremy, that's a good idea. But it's not always that simple because the scope has multiple zoom levels. And it also moves around. See, I can actually move the scope itself. And I can also like do hyper zoom, for example. Hyper zoom, right? So when I do that, that box changes. So Adam McGee, can we use all of the outputs simultaneously? The answer to that question is yes. You absolutely can. They are non-blocking. Cool. All done. So now we need to program. Let's switch to side cam, that camera. That camera's a little better. So let's clean up our mess a little bit. This is my project box for this project. I keep all the stuff for that project in one box. It is one of the ways that I keep things organized, if that makes sense. Each of my projects, I'll even Make sure I don't have my address on any boxes there. No, I don't. Flip this way, flip up that way. I have all my projects lined up right here, okay? And Ethernet adapters are here. These are the Apple III, what the heck is the thing called? The soft card. And then this bin over here, which was in the shop but now is not, is the bin specifically for the video adapter here. And I keep each of those, and that's this bin. I keep each of those completely separate with the parts for that project in that bin, because I base the number of how many I do of a run on the number of boards that I buy when I have boards made. But I will pre-buy certain things in bulk because it's easier to just keep a whole bunch of them around. Like the resistors for these projects, I'll buy them in bulk batches of 200 or 300, but one run doesn't use that many. So I use that to help me keep track of exactly how many for each project that I have. I try not to steal parts from one project for another project, anything like that. It just helps me keep track of exactly what I got. Clean up the bench a little bit here. Okay, so now we need to burn a ROM chip. So I need to find my ROM chips. Where did I stick them? They're here somewhere. I know they are. I know that they are. Stand by. I'm searching for the ROM chips. I know I took them all out and I put them at a very specific place that was not here for some reason. And see, this is why I put everything in one place, because now I can't find my ROM chips. This is why I put them all in one place. There's that. I'm going to need that for later. Oh my gosh. You get to watch Joe fumble and faff about like a moron. Welcome to Joe's scavenger hunt. There's the other thing I need for that for later. That's fine. I know where I can get one. I got them right up here. I'll just steal one from this project, and I know I have plenty. Okay, so there's our ROM chip. We need to program this ROM chip and stick it in here. So let's do that. First, we're going to straighten the pins using my pin straightener. Makes it go in the socket better. And we go over to the side, to the side, to the side. Can we do the thing? Can you see the thing? Can you see me doing things? So I need to open my programmer. Put the chip in. Open the program file. I have to find it. Stand by. That's going to be here. No, it's going to be on the server. Documents, development, Apple III. I believe it's this one. And if it's not, that's fine. So now we're going to program it. Device. Program. It's mostly zeros. Cool. And so the chip is programmed. And we swing back over here. And we put the chip in the dinghy. Just like this. It's done. One completed encoder. Now we get to plug it in. We get to plug it in and see if it works. Before we do that, we're going to check chat and see if I've missed anything. This is digital. Keep us a series of mounds. How many active projects are you currently working on? Well, new projects. I got this one going. I'm working on reverse engineering another Apple III product. I have at least 2 other projects that are for another person that are on hold due to manufacturing problems in China. Whenever that gets there, it'll get there. Never blank check that Model IC. Yes. Yes. I made a box of 2C parts and it's already full. Yes. So I've got several different things going on right now. Anything that just comes up. My friend Javier has something that he wants me to do for him. That is backwards. Is that backwards? Yes, maybe. No, it goes that way. So yeah, we'll see what's going on. So somebody asked in the chat, it'd be neat if it has a 3D case. Well, wouldn't you know, I made one. I made a 3D case for it. There it is. Yes, it is. I think I want to use this one though, because this is the final version that I got solder stuff all over. Yeah, this was a test version. They're even printed in beautiful brown PLA. They're printed in brown PLA to match. Why is that so brown? Can you like be like not brown? There we go. That's better. So we're gonna assemble this little whoop-de-doo that goes on there. Is that a little high? Yeah. This is designed to clear the tops of these perfectly, and if you don't get them all the way down in, it won't clear. Just keep that in mind. I mean, it's flexible. It'll kind of cramp down around it, but it's not a big deal. It's not the end of the world. But basically, that goes there like that. And get 4 of these little whoopie-doos. And they go through like that. And we get little nuts, little plastic nuts. And they go on the other side. Okay. There we are. You can do it. Oh, don't be stupid. I'm saying that to myself because I'm a stupid. That one goes on there. There. Little nylon nuts. You can notice I'm just doing this with my fingers, and it totally can just be done with your fingers. Although if you want to use a screwdriver and a pair of pliers or something to do it, you could do that too. Whatever is your fancy. Keep in mind that you can't, the STL file for 3D printing this yourself is on my website when you go to make your purchase. So if you want to print this yourself and have the ability to print it yourself, you can do such a thing. This one's being a little belligerent. I don't know why. It's being stupid. Don't be stupid. So we just grab it and do this. Stop being stupid. Don't do. Be smart. Be big brain. Did I cross-thread it? I probably did. It's good enough. Great. Okay. So yeah, you can't print this, but just keep in mind that if you buy this from me, you get the nuts and bolts with it. So you don't have to source your own nuts and bolts. So I'm going to clean up my mess here, because if I don't, I will regret it later. I try to keep organized as I go. And I know Steve is in the chat, and he's going to say, organized? What's that? Steve, Mr. Mac 84. So there we are. So we're going to switch a room. We're going to plug it all in. Nice work as always. It makes me feel a bit guilty for the subject of my last email to you. Don't feel guilty, especially since I am a bad person and haven't read your email yet, Jeremy. So don't feel bad about it. A good cross thread is better than Loctite. Yeah, but in this case, luckily, this is just plastic. If it's cross threaded, you just cut it and put a new one in. Imagine transparent or glow in the dark case. And that's the cool thing too. This is just, you can, this is available for download. You can download the case to this now if you wanted to, without any purchase. I just put the STL file out there for you. And just, you could 3D print it. You could send the STL file off to Shapeways and have them print it in whatever material you want them to print it in. Glow in the dark, clear. You could probably have it printed in resin if you wanted to. I'm just providing this 3D print in this luxurious Pantone brown color, just so it would match the machine, but whatever. Mac 84, organize. He heard me. He heard me say the magic word organize. So we're going to go ahead and move the camera around. I'm going to show plugging this thing in. Let's see if we can move the camera over here without causing any major issues. So can I get the angle? Can I get the angle in there? It's a little hard. Maybe I move the pooter up a little bit. Just a little bit. Here we are. We're going to zoom in so you can see the thing. This is hard. This is kind of a hard angle to get. Stand by. Shaky cam 101. There we are. I think we can work with that. So we're going to unplug this. Yes, you can hot plug it. It's no big deal. We plug in all of our outputs. Apple IIgs monitor is right here. CGA monitor is right here. And the third one has disappeared off the side of the bench somewhere. Stand by, I'm looking for it. Here it is. Color composite. All three. Plug it in. If I did it right, this will not go up in smoke. Yep, I did it right. And we come over here and we zoom out real quick. And of course, that's working. Now that monitor has gone a little bit blurry since it's been on because my Apple IIgs monitor is a little, how can we put it? It's a little tired. It gets, I've gotten it to where to the best it can be, but it gets a little blurry as it gets old. So we're going to swing way, 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 way back because I want you to see all of these on at the same time. Okay. CGA. Oh. There you go. And NTSC. If the monitor will ever turn on. You can do it. There you are. Now, the one thing you have to note with this here, it's hard to see. I'll get up closer on it. The NTSC output has a lot of noise on it. That's because the Apple III has a lot of noise on it. This is noisy in everything that I tried on. I've tried this output on 2 different Apple IIcs or Apple IIIs. I've also tried this output by manually mangling a connector to the back and bypassing my adapter entirely, and it is noisy anyway. It's just noisy. So if you buy this and you connect this to a color monitor and there's noise on the monitor, it is not my adapter's fault. It's your Apple III being a piece of poop, because that's just the way it is. Now I'm going to zoom in so you can see that kind of interference. There's basically really, really crappy filtering at play here. And I think you can kind of see it. You see these like wavy lines that are kind of, if you can see that there, that's just the output. That's just what comes out of the Apple III. It has literally nothing to do with anything. I can disconnect these other monitors, turn them off. It doesn't matter. It's just a mess. But with that, you have 3 different outputs that your Apple III can now output color to. Now, to compare these colors, let's actually, can I turn off a light? I might turn off both lights so you can see this better, so you can compare these colors. Does that work better for you? Is that too washed out? That might be too washed out. I might have to actually turn the lights back on. Yeah, I have to turn the lights back on. So let's compare these colors. Let me turn off my side cam so you can see that. That would be this and this. Cool. So the colors on the 2GS monitor over here are actually the most accurate. And the reason being is the digital to analog converter here was designed by Apple to plug into a standard RGB monitor with the color values they wanted it to look like. So this color set right here is what it is supposed to look like when you see it. It's kind of pastel-y. It's not very saturated. The dark green here is a little bit on the blue side. The aqua is a little bit on the green side. The light blue is a little purpley. The green here is more of a browny green. Brown and orange are fine. And there's no real red. There's just not, because this is an emulation of the Apple II color palette. The Apple II high resolution, or Apple II low resolution, or double high res, I should say. The Apple II double high res, or the Apple II low res color palette. This is an emulation of that. This is how they wanted it to look. Now, on CGA, it does look a little bit different. I'm going to tell you why, because CGA has a different set of colors than the Apple III is putting out, and they're completely digital. When you give the Apple, or when you give the CGA monitor bit patterns, it just puts out the color that the monitor itself was designed to put out for that bit pattern. Period. That's how CGA works. So, for example, here I have brown assigned to the actual color red, and then I have brown, the color brown, assigned to the actual color orange. These two grays are slightly different. The pink is more like a light red, light purple, magenta. They're a little bit off, and the reason for that is that's just the way the CGA palette is. I went with this specific palette after about 3 different attempts of trying to get the reds and browns right, the red, brown, and orange correct. And I think that this is going to be your closest match that you're going to have to that color palette. The color palette up here for NTSC is absolute garbage. It comes out of the machine that way. That's just the way it is. The brown looks like absolute poop. The orange looks like pink. The pink looks purple. This is just the way it is. This isn't even an Apple IIe or Apple II color palette. It's sort of close, but not exactly. It's garbage. It's just how it comes out of the Apple III. If you buy this, you can't blame me for that looking that way. They designed it that way. That's their fault. That's Apple's fault. That's just the way it is. Oh, hey, look! You can see where I get my parts from. So switching cameras back around to face cam so we can chat for a little bit. Brown looks red on CGA to me. It is. And we just talked about that. What if a capacitor were added to the NTSC output? That is a very good question. I played around with that. I played around with that many times in the past. And adding most capacitors to the NTSC between the output and ground just it makes it blurry. Because it's tending to keep high peaks and low peaks high and lower for longer. That's basically what the capacitor is doing. Is adding more power to the signal, and it tends to blur it out. One of the potential things you can do is put a capacitor inline, and it might filter out the high frequency stuff. I haven't tried that yet. So yeah, looks perfect on that on the 2GS monitor. It absolutely does. This color, these colors on the GS are just they're just absolutely outstanding. We'll get all up close and pretty for you. right about like that. There we go. And we'll flip to side cam so you guys can stare at that for a while. Seriously amazing work because it can lead to other improvements for other computers. Yes. Awesome. The Apple III was such a market success. Is that a joke? Unfortunately, you can see my GS monitor is really blurry. It's like sharp on the outside, but blurry in the center. There's something funky going on with that monitor. It's been recapped and everything, but whatever. You really want to try this adapter on the 2E RGB card. If you like, if you want to use one for testing, Adam, I can send you one of my test rigs so that you can play around with it and not have to worry about having to buy one to just play around. I will do that for you special. For those of you who just want one to get one, oh my gosh, how do you get one? So that's the question. So you're going to want to go to jcm-1.com and go down to the Apple III section, or go to the store and go to the Apple III section and click on that. And it'll be right there. I can also give you a direct link if you just hang on just a second. I will give you the link-a-doodle so you can go straight to the placey place. It's that, it's that, it's that. Here it is. Right there. There it is. So you can go there and grab one. I've spent quite a bit of time on building this and designing this, and I think it's been a really fun project to learn a little bit about how RGB stuff works, how the Apple III is such a randomly weird machine, and to, again, add some love to the Apple III that's just not there. There are a lot of Apple IIIs out there that are languishing. A lot of people like me have them in their collection, but they don't do anything with them because it's like, the cards that came with them are impossible to find because nobody bought cards. A lot of the Apple IIIs that are out there are in garbage shape and need to be repaired. And I'm doing every effort that I can to find all of the little weird things about the Apple III that are preventing people from wanting to collect and use them, and fill those niches so that stuff is out there. So if you do get an Apple III, you're going to have the bits and pieces you need to either fix it or make it actually usable. And that's what I've really been aiming for. I hope that I'm achieving that. I don't know, maybe. Well, that was kind of all that I had for the stream tonight, unless you guys want to hang out for a little bit more and talk about some of my other projects. Retro Techie, your Apple III keeps your house from blowing away. Yeah, they are heavy. They're insanely heavy. Other projects that I have going on right now, I've got a color classic that came in from my buddy Javier, who may still be in the chat. I don't know. Speaking of still in the chat, Rudy had to run. See you, Rudy. If I missed you, I'm sorry I missed you, but see you. But Javier sent me a color classic that he needs it has an analog board problem or something, doesn't turn on. So we need to fix that. And then he also sent me a couple boards that we can use one or two of them to do a Mystic upgrade on that color classic, which is cool. Mr. Adam McG in the chat right now. I met him yesterday and we traded some cool stuff. And he gave me an LC550 that I can use to be able to test color classic boards and LC boards in, so that I can actually take my color classic and do a Mystic upgrade on it as well. In theory, I could probably put the LC575 board in the 550 and then effectively have the same thing without having to mod my color classic. But I wanted the 550 because it can use both boards. So it can have one machine for diagnosing, repairing, and testing more people's things without having as many machines in the pile back here. So that's the thing. What else is going on? Ooh, Adam also gave me a really cool, like, funky Apple II card that it's like an X10 card that you plug into, like, your power and then plug the card into your Apple II. So you've got like an extra power cord coming into the back of your Apple II, but it sends networking data over your house power lines, so you can control X10 things. But there's a software for it. So that's going to be an interesting project at some point. If I can make my Mac SE have color, that would blow my mind, or some type of an adapter. Yeah, you would have to have a video adapter to make the Mac SE do color video. What else do we have back here? I'm just looking at my pile of stuff. So many things. I am reverse engineering the Titan 3 board set for the Apple III. Stand by. That is this right here. This is the first board that I have. I have that. Focus on it. Focus on it. Focus on, you stupid. Like, can you even do it? Can you do the thing? What are you focusing on back there? I have no idea. Whatever, it doesn't matter. I've got the first board stripped. I have it almost completely traced out and copied, so to speak. And the next step on that is sending, well, proofreading it to make sure it's correct, and then sending us a batch of those boards out for production, have them come back so I can populate it and see if it actually works as designed, as if it were an original board. If that works, then I can do the second board. For any of those who don't know what those are, the Titan board, the Titan board set, as it's called, the two boards together are put into an Apple III to effectively make it an Apple IIe. So if I get that set, that will allow the Apple III, anybody who has an Apple III, to run any Apple IIe software, well, almost any. The compatibility is like 98%. They can run just about any Apple III software or Apple II software on their Apple III that they want, which will make the Apple II or the Apple IIIs that are out there infinitely more usable for folks who have them in their collection. You know, there's a SCSI video card that works on an SE, but good luck finding one. Yeah, those are almost impossible. If that SCSI video card uses off-the-shelf chips and somebody has one, get a hold of me. So yes, it makes a very heavy Apple IIe. Yeah. How much these things weigh? They're like 27 pounds or something. They're nuts. They're absolutely nutty heavy. I can actually show you. Do I have that design up? Maybe I can show you the actual board layout. Stand by. I need to go here and go here and go here and open that. Loading. Get your board loading. Yep, there we go. So now I have to click a button to show you screen cap left. There it is. So, yep, there's the Titan set, the Titan board set. I can get rid of all these. So that's the front side of the board and all the traces. I got most of it done. I still have to put the pads in here and down at the bottom. I'm sure there's a couple traces I've missed. There's also one bodge wire right here on the front side of the board that I need to, I want to get it somehow routed onto the board itself. It kind of flies up here and goes over to this connection. If I get that routed on the board itself, that'll be cool, because then we don't have to have that fly wire. And then we've got the back side of the board right here, mostly done. I think there's a couple spots where I still have to do a couple of traces, but I have to grid the board out and go through it with a fine-tooth comb, make sure I haven't missed any connection doodles. I have to put the pads down here at the bottom as well. But as you can see right here too, these colored spots, each place where there's a colored spot is where a bodge wire runs. Yep, here, look, there's a trace missing right there next to that yellow spot. But each place where there's one of these colored spots, that's where a bodge wire runs from that color to that color. So I got to like find a way to like route these up through there. I might be able to do it on a multi-layer board or something like that. I don't know. So, yeah. Flipping back to the front side of the board, somebody had a question about the board. Go there, hide that layer. Is that RAM there on the left? Adam G said, yes! Yes, it is. This is all RAM. It is 128K of RAM, because basically this board set is completely turning this into an Apple IIe. This is a 2, 3, or 4-layer board. This right now, the original is a 2-layer board. Yes, the original is a 2-layer board. I might go to a 4-layer board, so that I can run these couple little bodge wires on a couple of internal layers, so I don't have to worry about like trying to fish stuff around and find ways to do that. Looking at this now, I see another huge trace right here that's missing. I still have to go through this with a fine-tooth comb and find any missing traces that I've got before we finalize this. Yeah, the game I/O up here isn't connected to, oh, because it's not connected, never mind. I thought that needed to connect to that ground plane, but whatever. But once this is done, then I can, like I said, I can spin that, kick it out, whatever. Fill it with vintage MT chips if you don't want it to work. Hold on, stand by. Let's see. Let's look at the original chips that were in it. Nope, those are not MT chips, so I don't have to worry about that. This first run, 3 plus 2. So does that make this an Apple V? Sure, if you wanted to. This board, of course, is using 128 kilobits, or yeah, 128 kilobytes of dynamic RAM, 1-bit RAMs. I have a feeling that if I work hard enough, I can design this to take a single static RAM chip. I don't think it would be too difficult. The RAM design on this is nowhere near as difficult as the built-in RAM design on the Apple III. So that'll be a fun thing. Aura Systems made SCSI Graph 2, a SCSI peripheral that provided color video. If we can find one of those, that would be cool. Yes. So like, yeah, if there's like a generic video or SCSI video card that's out there for the app or for the Mac that uses Jelly Bean logic, it doesn't use custom chips, I would love to have one of those, because that means then I can copy it and then I can make more of them. That would be cool. Yeah, the Apple IIe and TC use the same chips. I have the IIe and 86 to use 4 chips instead of 16. Yeah, because basically what they did in the they went to 4-bit ROMs instead of 1-bit, or 4-bit RAMs instead of 1-bit RAMs. So each RAM gave half a byte instead of 1 bit. And so that's the trick. And I update this again so an entire bank is 1 chip. And then 2 banks is also 1 chip, because then it's just the high bit that's used, the bank switch chip bit at the top. It's just the high address bit of that chip. And it just switches between the 2 halves of the RAM. The trick is there are some, yeah, it's really tricky doing dynamic RAM to static RAM conversion. It's not exactly straightforward. I don't think it would be that hard in this particular case, but it might be. You have to deal with the CAS and RAS lines and how those effectively translate to the address enable stuff. I think you have to have a buffer in between it to buffer or to cache, to register the CAS line and then feed it over when the RAS line comes through, because they're not on at the same time or something. I don't know exactly. I'll have to do some research on it, but I'll figure it out. At this point, I'm just mumbling and not talking about anything important. But yeah, that is everything that is on my plans for now. Back to Facecam so we can chat for a little bit. Yeah, that was the Apple III Universal Video Adapter. That is now available at jcm-1.com. If you want one, go grab one. They're $34 built and completed, $19 as a kit. And you can also get the 3D printed case with it as well. Thank you all for stopping by tonight. I think I'm going to call that a stream. We're at about 2 hours, and it sounds like a good place to stop. I'm also getting a little tired myself because it's getting to that time of day. But again, thank you all for stopping by. Remember to hit the like button. Hit that like button if you liked the stream tonight. Hit the subscribe button if you're not a subscriber. If you're not a subscriber, why? Hit the subscribe button, hit the bell, and you get to know when I do these cool things. And we get to hang out and talk about old nerdy 8-bit retro tech together. And yeah, that's really all I had. Again, thank you all for stopping by, and have a great evening. See you later, folks.